Hello everyone and welcome to this Midas GTS NX webinar. My name is Adam Kane. I'm going to be taking you through proceedings today. I'm one of the technical support engineers at Midas UK. And I just want to do a quick sound check with everybody just to make sure you can hear me and visually see my screen. So if you could raise your hand or place a comment in the GoToMeeting dialog box, I'd appreciate it. Thank you. I see a few of you have raised your hand now. I'll just go through and say what the title and everything like that. So this is Midas GTS NX, where I'm going to be taking through 3D geometry modelling, mesh generation and analysis for sequentially excavated tunnels. So we're just going to continue. Right, so just to go through some ground rules and general housekeeping. I know you can hear me and you can see my screen, but if you want to maximise the screen, just click on the two overlaying boxes in the top right hand corner, and if your screensaver happens to kick in, either just wiggle your mouse or set it to off now in the settings. Additional GoToWebinar instructions. You click the red arrow, it will compress it down to a narrow strip. If you'd like to ask any questions throughout, we will be able to answer them, and there will be somebody on standby from the technical support team to answer any questions, or we will send you an email after the webinar is finished. So just go through some of the contents that I'm going to be highlighting today. So just going to first of all talk about sequentially excavated methods, for Shotcrete and things like that. The features of the sequential excavation method, the concepts of the sequential excavation method, or SEM, mesh generation, loads and boundary conditions, and the post-processing, where we'll be jumping into the modelling space. So just to briefly talk about the sequential excavation method, which is for tunnel construction and is also known as the New Austrian Tunnelling Method, which is the NATM, or the SCL, which is the sprayed concrete lining method, with some modifications done to the original NATM method to make it suitable for applications in soft ground. The SEM, either by NATM or SCL, can be used for practically any type of ground profile, and hence it can support any type of tunnel sections, be it circular, horseshoe, ellipsoid, or any other irregular shape. In the SEM methods, the ground also plays an important part in redistributing stresses around the tunnel cavity. The support requirements are more economical. The SEM is well suited for applications in soft ground and in rock. So just the SEM, the excavation drift cross-section for excavation. The time and duration at which supports are installed depends on the ground geology. For a good quality ground, the maximum unsupported excavation length tends to be much higher than what is allowed for in the SCL method. The type of structural supports also depend on the ground type, be it rock bolts or Rockbox and Shotcrete, which are used in strong to soft rock types of ground, whereas steel ribs and lattice girders with Shotcrete or cast in place or concrete segments are used for mixed ground to soft ground situations. For tunnelling in competent rock, even full face excavations can be achieved, but in soft ground conditions the excavation phase should be subdivided into heading, drifts and invert. Supports are usually installed every other round for soft ground. The support should be installed as soon as possible, so the minimum ground stand-up time, essentially. So for poor ground conditions or to protect damage to adjacent structures due to soft ground and tunnelling, ground improvements prior to on-start of works is required. The recent examples was ground freezing underneath the Westminster Abbey during construction work for the London Underground. As it was mentioned in the last webinar, the predictions from a finite element software should always be checked with the field measurements out on site. So the ground surrounding the excavation cavity is an important medium to redistribute the stresses. To stabilise the excavation in softer weak rock, the first pass of shotcrete lining is made up of low stiffness so that it undergoes controlled deflections to mobilise the shear strength in the ground, but at the same time is stiff enough to provide structural support and prevent any sprawling. Since the shear strength in ground is mobilised and used as a support measure, stiff supports are not required, so stiff supports attracts more loads and hence they increase design cost. So by using the inherent strength of the ground, support requirements are kept to a minimum. In the sequentially excavation method, the type of cross-section chosen depends on the nature of the ground. So a curved linear shape is preferred to redistribute stresses due to the excavation. In competent rock ground, inverts are normally flat, but under soft ground conditions a rounded invert is chosen for a more gradual stress flow across the tunnel cross-section. So the advancing tunnel face causes changes in the initial vertical and horizontal stress conditions of the virgin ground. At the tunnel face, the stress flows in three ways: around the tunnel opening, arching ahead of the tunnel excavation, behind it into the newly constructed initial lining in the longitudinal direction, and to the sides of the opening in the perpendicular direction, which I've just highlighted with the mouse. So, such as the three-dimensional state of stress can only be analysed through a three-dimensional finite element analysis. So what we're going to do now is take you into the modelling space. So I'm just going to show you a fully completed model of a sequential tunnel, and just want to hide the ground conditions so that you can actually see the tunnel in behind. So as you can see there, just hidden the ground conditions completely, and you can see all the rock bolts and the galleries and the connecting tunnels and everything. You can see all of the excavation and the segments of the ground conditions. So just want to turn on the shotcrete just to show just the shotcrete on its own, and then just to show you the rock bolts as well and the other shotcrete. So as you see there, that's the shotcrete layer and also the rock bolts in behind. So this is just an overview of what I'm going to be modelling within the working space. So just to basically show you everything, and just going to take you through and show you how easy it is to model this sequentially excavated tunnel with the intersections and everything. So just to show you all the mesh and everything like that, and switch everything back on, take you through the different viewports. Now I just want to take you back into the presentation, then we will be going back to the modeling space a bit later. So depending on the ground conditions, different constitutive models can be used to model stress strain behaviour in the soil or the rock. The Mohiculum or the Drucker Prager are good models to perform preliminary analysis. The Hock and Brown models can be used to model non-linear elastic stress strain behaviour in rocks, whereas more advanced material models such as the modified Mohiculum with stress and cap hardening behaviour and the Jardine for small strain stiffness can be used to model normal to soft, over consolidated and stiff soils respectively. So Shotcrete is modelled as curved plate elements for 3D analysis. The behaviour can be considered as elastic or elasto-perfectly plastic. If the ground quality is poor and stand-up time is low, the Shotcrete can be applied to the face as a temporary support, which is then demolished as the heading processes, and it basically goes through the Shotcrete layer. The hardening of Shotcrete over time can be simulated by boundary conditions. The soft Shotcrete's modulus is taken as 1/3 of its 28-day strength. Rock bolts are modelled as truss elements. If there are steel lattice girders in place inside the Shotcrete, then the combined stiffness of steel reinforcement and Shotcrete is used as equivalent Shotcrete stiffness. So what I'm going to do now is just take you back into the modelling space, and I'm just going to show you the initial model. So I just want to switch over to that in the bottom tab. So there's the initial model, and you see all the surfaces and everything. They're going to be extruded, and the planes are the lines that they're going to be extruded along. We can also bring this in from a AutoCAD file as well, so you can actually bring in anything you've made in AutoCAD. You can bring it straight into the modelling space and then carry out the extrude functions. So for now I'm just going to pick some surfaces and extrude them along a line. So I'm going to do that for all of these different sections. And we just pick the start point and the end point and the length. And you can just give it a preview, and then you can see that geometry has actually been created, so the solid element. So I'm going to do the same with all the other solid elements we have in place. So same again, just select the surface and the start and end point, which is the value, and then hit the preview and then extrude it. So I'm just going to do all of these, so bear with me. Just showing you how quick and easy it is to move through everything. Okay. Just make sure I turn off the layer so it doesn't get confusing on which ones I've done and I haven't done. First point, end point. Click on the little arrow to say we want the length that's chosen in the working window, preview it, and then just click OK. There you go, and that's all the connecting galleries and everything nearly done. That's your length, and then OK. And that is every single one created already. Now I want to create the ground conditions around the outside of these. So just using the surface at the bottom, just want to extrude that along the same plane as before, right from the top to the bottom, and then it's been created there. Right, so that was all the actual surfaces that have been created, the solid elements. So just select the solid, we just want to make that transparent. So we can look straight through it, and that means we can select everything. So we just set the levels of transparency as well to make sure we can actually see the surface around the outside. So now I'm going to focus on the automatic intersection of the solids. So just going to generate the shared nodes at the common faces between the different solids. So just going to select the auto connect. Now that's auto connected all of the galleries and all of the shapes. So you can visually see straight through that. And now I want to check for the common nodal points. So we can give it an accuracy as well, just to make sure. And that's checked all of the nodal points there. Now we can look straight through the actual shape itself. Now I'm going to put so what I'm going to do now is, now I've got the side, I'm going to create a rectangle over one of the entrances to one of the galleries, and then I'm going to use that in order to create splices through the solid object. So that will create our stages going through. So I check that's in the right place. So that's in the right place, and I want to multiply this over the distance of the tunnel itself, and then create the different segments. So just going to transform that and vector it over 2 points, and then just create a copy and make sure we can actually put the distance in. So 4 meters, and want that duplicated 25 times. So that's created it into the segments. Now using that, I'm going to select the 2 solids and then all of the so just delete the first and the end one. So just selecting the solid, so just the top and bottom, and then using the surfaces just to separate them, so we can select it from the working tree to make it easier. So just drawing a box over all of them, and that's all of them selected. And then we just want to divide the touching faces as well, so any touching faces, and delete the original, and also delete the tool, as in the first plate or the first face that's going to be splitting the element up. So I was just bear with it a minute. Right, so as you can see, that's all been split up. So all the solid elements have now been split up into their separate entities. Now we'll just focus on all of the other tunnels as well. So just going to have a bit of a Blue Peter moment, and here's one that I made earlier because I don't want to take you through the same sequence over and over again. So in this model, all of the segments have been divided, so as you can see there displayed that every single segment has been divided into its different solid parts. And now what I want to do is do the mesh generation for all of the solid elements. So just had a question come in, so just bear with me. It's going to go over to the message window. Right, I just want to bring it up. So can non-horizontal ground layers be created? Yes, we can. Yes, we can create horizontal ground layers. You can include borehole locations from a DXF file as well, making it easy to import and bring across. You can also define the ground layers by inputting the upper and lower bounds of each soil type. So what I'm going to do is I'm just going to share an example by using the bedding plane wizard. So I just want to highlight and give it a couple of values and a name. So just give it ground layers, give it a name of 1, and this will be each individual borehole. So I just want to put in some of the values and add them. So just you can add the depth of each one. So this is each soil layer going all the way down through. And there you go. So just want to create a second. And as you can see, we could put a different value, a different location, a different point. So this would create the layers going across. And obviously the more layers that you create, so say if we've got 4 points instead of just the 2 that I'm creating, then you will have a more detailed layer strata. So there's one more point. So just going to give you the layers. Okay. The third one added. Just want to preview that, and as you see, though I put them a bit lower, you can still see that you've got the layers going from one point out to the 3 side points. And that's the ground conditions being created. So I better get rid of those so it doesn't get in the way. So just get rid of those, just delete them now. So just select the surfaces and all geometry. I just want to delete that. Right. Right. Let's go back to the original view. Now before I do the meshing, just want to take you back into the presentation. Then we'll continue. So in the 3D analysis, which is performed with the finite elements, the analysis requires discretization, or the splitting up of the 3D model geometry with the finite elements. The mesh is generated for ground, excavation volumes, for the tunnels and the interconnections, the shotcretes and also the rock bolts, so pretty much everything within the working space. In a finite element mesh, elements behaviour such as curved plate for shotcrete is linked with its structural material properties, so be it concrete. So I'm just going to go over into the modelling space and show you how to mesh and show you all of the different structural elements and everything like that. So just to take out the just some of the material and the different material types. So to show you the dialog box where we've got all the drop downs and the different model types as well. So obviously you've got vehiculum and everything there, different material models, and also the shotcrete shell. So just show you the properties and the material properties and everything like that, and just how it's a uniform thickness and the different materials that are within there, so we can change it and we can import from a Excel file, and we can also export to an Excel file as well if you want to check the results or change anything. So now just going to go to the top view and then mesh either end of the tunnel. So just want to select that, so just select by the solid and just highlight the intersection between the gallery and the actual tunnel itself. Now I've just selected all, just want to use the auto mesh function, so just set it at 1.5. And then just apply that, so the mesh will be automatically generated. Just take a couple of moments. So with this window, as you can see, it's just meshing all the elements very quickly, and it's created a tetra mesh as well. So combining the two, I just want to bring everything back online, just hide the main body of the ground and do either end. Now let's just carry that out quickly. Go through and then do the other end. It's all very fast and efficient, and then just a few down the middle. So just select them a few more, and then once I've done all of these, then I'm going to switch over and show you the fully meshed model. And then we'll focus on extracting the shotcrete from the shell elements from the solid elements, and then move on to look at the rock bolts as well once that's been done. So just go through all of these. As you can see, you've got a very fast frontal solver that meshes everything efficiently. And there you see all the meshes that have actually been, the mesh has been created from the solid elements we previously had. So, and you can see the detailed connection between the gallery and the tunnel intersect. I'm going to go over and just go into the next model, and here's the fully meshed model now. So I just want to delete some of the ends where once I've extracted the shotcrete elements. So just do the mesh, and then what we can do is convert or extract the shell elements, be it the shotcrete from the actual solid elements. And we will end up with a shell at the end there, so just to quickly do that, once everything's selected, and as you see, all of the shell elements have been created. I just want to select all of these and isolate them, and then just show those. So now that I've got them, I'm going to go to the top view and just delete some of the ends. So that's selected. Let's go all the way around and select each one individually. So that just makes up the ends of the tunnels, the entrances. So I just want to select the base as well. So now they're deleted. I'm just going to select the bottom of each tunnel and delete that as well. Now notice if you go one way, then it will only select everything within that working space. If you go the other way with the mouse and create a dialog box, then it will select absolutely everything. So you see the bases now all been selected. I just want to delete those as well. So now that's the tunnels that have been created with the Shotcrete, and we have all our solid elements to split up as well. So we can generate all our construction sequences a bit later on. So now I'm going to generate the rock bolts. So I'm just going to select one of the galleries or one of the tunnels and generate the set from there. So I'm just going to go down through the works tree and select one, bring on the template, so the curve template, and select all of them. So these are the rock bolts. Those RB. So first of all I want to mesh these. So just use the edge function and select the previous, and then just want to generate a mesh. So you can split up into a number of divisions. We're just going to select one and give it rock bolt 1 as well as a name. Apply it, so that's now meshed the rock bolts, and now I'm going to translate them so they're in the middle of the section. So it's going to move them 3.5 meters. And then just use the preview function. As you can see, it's moved. So now that I've moved these sections, now I just want to copy them to make sure they're on every single section going throughout or every single mesh set for the central tunnel connecting gallery. So this one, distance is 7 and number times 13. That goes throughout all the way to the other end, and make sure that all these, just preview it, so it's 15, we've got to go all the way to the end. So that's the rock bolt that's been generated for each individual section going throughout. So I'm just going to hide all the rock bolts that we've just generated now, and then I'm going to just show the main tunnel. So we'll turn all these off. So those have all been turned off. I just want to select the main tunnel, so just go back to basic, select everything. So that's all been selected. Just want to display this, so just show only. So now I just want to show the element coordinate system, so just go out to nodes and then the element. Now in the, so I just want to create so you see they're all pointing outwards, going in the same direction. So I just want to make sure they're all uniform. Now we're just going to create, this is going to create the interface between the element and the Shotcrete lining, and also the ground conditions on the outside. So it's going to activate the ground conditions, so just to bring them back online. Then we'll just show that interface. So now we've got the ground conditions, I can create the interface between the ground and the Shotcrete lining. So just selecting the shell elements, and the direction is normal, and then we're just going to use the strength reduction factor of 0.7. And we just selected all the objects. As you can see, we've got 1536 objects selected, which are all the plate elements along the outside of the tunnel, or the shotcrete. And you can see the interface. So there is the interface between the two that's been generated. So I zoom in a bit there. And then just to bring everything back online. Now you can still see the interface between the shotcrete lining and the ground conditions. So I just want to go through the analysis and look at the boundary conditions. So we're just going to create some user-defined supports around the outside. Then we can automatically generate these, so just to give it a name, and ground supports. And that's generated the ground conditions around the outside and all the boundary conditions. So just I just want to put some loading conditions on here as well. And we can just put a pressure load on the surface, so just select the top and just create a pressure load onto that surface, and I've selected the right plane, so as you can see that I just put a pressure load. So just 50 kilonewtons, preview it just to make sure it's there. That pressure load's in place, and just click OK. Right, so I just want to create the gravity load as well, a bit of self weight. Okay, and now that's been generated for the whole model. It's indicated with that red arrow. Now I just want to add the construction stages, so we just want to generate construction stage for the junction analysis. And we can add different stages as well throughout. And now I want to go and show you the next part of the modelling, so just the next model. I just want to show you the construction stages within here. So you can see that we can take it to the mesh view and check on the different construction stages. You see I've generated all the different construction stages going throughout and put in all the different conditions. So we've defined the water table as -100, and we've got the different stages, and you can select what's active and what's inactive. I'm just going to flick through the construction stages and show them quickly. So as you can see, at different construction stages you've got different active boundary conditions. You can also see it visually in the background, what's being removed. So the invert of the tunnel has been removed, and then in the second stage it would be the lower section. So I just want to flick through these in more detail, just give you a more graphical representation. So I just want to just quickly hide this mesh set. Right, now that I've visually got it on the screen, I can flick through and simulate all the different construction stages. So we just go through one by one. As you can see, it's actually going through the construction stages, and then you can see the shotcrete and the rock bolts being put in place, moving through the tunnel, and then the next segment, and so on and so forth as it goes throughout all the different construction stages. So now just looking at the post-processing mode, so just going to carry it through the analysis now. Take a minute. So now it's just carried out the analysis, just want to look at some of the results and look at some of the displacements. So we can look at these throughout the different construction stages, which I'm going to highlight now. So just to show you some of the total displacements. And as you can see, we've got a bar down the bottom here that we can just quickly clip through and look at the different construction stages. So we can look at the real deformed or the undeformed shape as well. So there's the deformed shape, and also the deformed shape with the existing as well, so you can actually see how far it's deformed. The Z direction. So now we want to look at the probe test, so just to move on. I've got the probe dialog box, and with this we can actually probe any point on the structure, so be it the plate elements or the solid elements, it doesn't matter, and this will change throughout the construction stages as well. So the values will all change if we so wish to go through the construction stages with the probe test. You can also change the colour and everything like that, just to give a bit more of a user-friendly feel. You see the values changing. So I just want to isolate one of the tunnels, and then we're just going to extract the results of the crown and look at the ground mesh. So just to make sure we're in the pre-processing, so we can actually select everything from the model window. Just want to show you that. Just want to so back into the post-processing, and now we're just going to do a few more, check out the displacements again. So on the ground, so you can see there, throughout the construction stage you can see the stresses going through the ground as well, just by using the works tree, which is the quick and easy method of doing it. So we just want to look at the edge type and just change it over to the feature mesh. And we can also look at the actual mesh as well, the wireframe. So we're just going to look at the crown now. We're just going to extract some of the results. So just the displacement results, and just looking through the totals. I just want to set them. You can look through the different steps as well. We look at the TZ. So just to highlight the nose going down through the crown of the tunnel, and just look at the table results, or the tabulated results. Okay, those are all the results from the crown. You can see all the different nodes going across as well from the selected, what we selected in the window. So I just want to highlight all of these, and we can actually export them to an Excel sheet and show in a graphical representation. So that is the graphical representation. So you see the curve down through each individual step. I'm just going to get rid of that one now quickly. Go back in. And I just want to show you the rock bolts. So just select the rock bolts and the mesh. So just to show only these. There we go. And I've isolated the rock bolts. You just want to see the forces results. So I just want to go down to the bottom. So for the truss element, so the actual forces, I can see that going throughout the different construction stages as well. All the connecting galleries there, and the stresses. So now I'm just going to show only the shell elements and the structural forces and moments within these. So just isolating the shotcrete layers, and then looking at the bedding moments, going throughout each individual construction stage. As you can see there, all the plate elements on the outside and the moments that are distributed throughout. Just looking for the next forces. Okay, so throughout the construction stages, so just pick one at random, and the shell element stresses. And we can also look at the Von's miss as well. So we're just going to look at the mesh again, or the ground conditions, and then show you an on curve diagram. So it's going back to the original. Showing only this. So just look for the mean effective pressures, and just go back to the original view. So we can just do the clipping planes through this as well. So as you see, you just move the clipping plane straight across. And we do it in any angle, and as you see, it's quick and easy to move all the way through it. And you can add the clipping planes as well, so we can combine them. So as you can see there, the clipping planes going through two different surfaces, showing the whole tunnel. You can look at the different mesh and everything like that, so as you can see visually, it's very good in Midas GCS. So just go quickly back. So the original clipping planes, just want to do quickly go into the 49th construction stage and turn the mesh edge back on. So there we go. I'll just move it slightly. Right, so just to go on, we just want to go to Tools, and I just want to show you the Export 3D PDF. So from this we can generate a 3D report. I just want to highlight some of the areas, so I'll just bring it all up on screen. So what you can do, you can select any of these, go down through. So those are all the construction stages highlighted. So I've already generated the 3D report because we don't want to waste any time. So this has been generated. I just want to show you that I can flick off the ground mesh and hide it. You see it's all open. As long as you've got Adobe 10, then you can open up this document. You see there, you can see all the construction stages and everything and all different meshes. You can flick through different pages so they can see the mesh on this section. And this is a 15-page report, so you've got all the different construction stages throughout. So just the loads. And the different construction stages, so just get the solid wireframe. So these are all the results for the displacement throughout each individual construction stage. And you can see the construction stage changing at the top, so construction stage 30 and then going through. So I just want to show you some neat features, so you can, like you can in GTS, you can also do the clipping planes and everything. So here's some clipping planes through the object, through the tunnels, to show you all the rock bolts and everything like that, and the connecting galleries. And just you can manipulate it in any fashion you wish, basically. So you can switch all the solids on, or the solid wireframe, change any of the views, look at the real displacements, do a measurement, so just a 3D mesh measurement from one end to the model to the other, as you can see there, and you can actually display that and edit it, and then when you want to share it with someone you can. So move that 3D report, move the measurement around. So then they come up in the works tree as well, or type worktree at the side so you can actually see the measurement and bring it on board. So now I've shown you the 3D PDF. I'm just going to take you back into the presentation, then close. So I've just gone through all of these within the modelling space. So that was all the loading conditions, self-weight, surcharge and water pressures, and supported conditions for the boundary conditions. Then went through the construction stages and briefly tapped on what you could do, and you can also concentrate on the non-linear analysis controls. We also went through the post-processing for the results extraction, the settlement profiles and the forces and moments, and then we even looked at the 3D report at the end. So just want to check the question box and make sure we've answered everything. So just had a few more coming on. I'm going to answer a few of these. So is it possible to generate high order elements? Yes, you can generate second order elements, and the hetra, tetra and pentra solid planar elements can be generated. So I'm just going to go back into the software and just show you that quickly. So I just want to close that dialog box. Let's go through the pre-processing. I'm just going to show you how to quickly do this. So creating the second order element, so look at the 3D. So just to generate the mesh, and we've got the mesh controller, and you can generate the higher order elements here by ticking on the box before you generate the mesh itself. So in GTS NX we have two automatic mesh systems, which are the default tetra, which and a hybrid, which generates a combination of hexa, tetra and penta elements. So the next question is, how are the interface properties defined? So the interface properties can be defined between a line element, for example a beam or a planar element, or a wall and the adjacent soil. So the user does not have to define physical thickness of the interface manually. There's two different modes you can use, which is the wizard input, which is the reduction with the reduction factor for C and phi, and then the properties box, which is the input of the stiffness in normal and the shear direction for C and phi. So just to highlight those in the dialog boxes. So it's giving us some values going all the way down through, and the friction angle and everything like that. And just do the tick on the interface. So I'm just going to take the one final question. So how are the nodal connections between Shotcrete and ground, or how are the nodal connections between the Shotcrete and the ground? How is it guaranteed? I think that says. So the Shotcrete elements are extracted from the face of the tunnel, solid elements, which are demonstrated in throughout the GUI and the user interface. So the nodes are automatically coincident, created between the two in the same place. So now I've answered a few of the questions, so I'll answer the rest in an email form because we've run out of time. So just to close, if you do want a bespoke presentation or demonstration of the software in your office, then obviously just call the number on the screen or contact us via email. We'd be happy to come along and talk to you. My name's been Adam Kane, and I'd like to thank you for participating in this webinar, and I look forward to seeing you again soon, and make sure you check out all of our YouTube content and all other additional online services that we provide. Okay, thank you.